Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. Today we are going to be looking at the Honda Integrated Motor Assist hybrid system used in many of their vehicles since the year 2000. Honda has this little electric motor. It's a 20 horsepower, 15 kilowatt electric motor that is sandwiched between, as you can see it's really thin here, between the internal combustion engine and the transmission. This motor assembly, and we'll learn more about it here coming up shortly, has been used with as small as a little 3-cylinder engine in the original Honda Insight. It's been used in 4-cylinder engines with the Civic hybrid and the CRZ and the newer Insight. It has been used with a V6 engine in the 2005 through 7 Accords, and it adds additional power to the engine by bolting this electric motor rotor right to the crankshaft of the engine and helping it rotate with an electromagnetic field. So this is a synchronous AC motor that is used to help the crankshaft rotate as we drive down the road. There have been several revisions and improvements to this system since it came out in the year 2000. And to my knowledge, I believe the last vehicle model year that it was used in was a 2016 for the Honda CRZ vehicle. So let's take a look at the components involved with the Honda Integrated Motor Assist system, and then we'll take apart some of these components. We'll learn how to remove and reinstall the electric motor, rotor, and stator assembly, and see what's unique to the Honda system compared to other systems that we will be looking at in future episodes and ones that we've seen already in previous episodes. So let's begin with the wire harness. So right here on the table I have the 16-foot long wire harness that we looked at in the episode on high voltage hybrid system vehicles. This is a 2-connection DC high voltage. This connects to the battery in the trunk on, say, a 2010 Toyota Prius, and the other end would connect to the inverter with converter assembly up underneath the hood. So that's a 2-wire system. But Honda does it differently. Honda, as you can see here, has a 3-wire system, which means this is not DC. This is a 3-phase AC voltage, and this harness is just as long as this Prius one, but this is the Honda Integrated Motor Assist 3-wire cable that runs from the inverter and converter assembly that's behind the back seat on those cars up to the Integrated Motor Assist motor, rotor, and stator assembly that's sandwiched between the engine and the transmission. So a very long 3-phase cable. This is AC voltage, where on the Toyotas it's a DC voltage. As a matter of fact, Honda's the only one I'm aware of that has this big long 3-phase cable going from the back of the vehicle all the way to the front. There may be some others, but for the most part it's a DC cable, still high voltage, just like the Honda one, but it's 3-wire instead of 2-wire. Alright, now let's look at some other components. Okay, the next component we want to look at is called the Intelligent Power Unit, the IPU. And this entire assembly here goes behind the back seat on whatever Honda Civic Hybrid or Accord or CRZ or Insight. Of course, the first Insight didn't have a back seat, but behind the back seat of the later ones. The Intelligent Power Unit contains the inverter assembly that takes our high voltage DC and inverts it into three-phase AC. It contains our DC to DC converter that takes our 158.4 volts on this particular model. It could be 144 on other models, and steps that down to about 14.5 volts to charge the low voltage charging system on those vehicles. This contains the air conditioning system driver for the electric air conditioning compressors that all later model hybrid models had. The early Civic and early Insight had a belt-driven one only. If you wanted air conditioning, then you would have to sacrifice the idle stop mode where the engine would shut off when you pull up to a stoplight or a stop sign or stop driving the vehicle. On later models, they had some weird belt-driven and electric AC compressors, and then just pure electric air conditioning compressors after that. But this one has a driver for the electric air conditioning compressor. These are air cooled. These are not liquid cooled. So there's a fan built into this. It pulls in air from the speaker shelf, puts it through the whole system, and then blows it out through a vent into the trunk system, where it can go out the little pressure relief doors in the side of the body. So let's take a closer look at the intelligent power unit now. Right here in the bottom of the intelligent power unit, that hole right there is where the three-phase cables right here would come in and connect to the inverter assembly. On the front of the intelligent power unit, this entire front cover unbolts. But before you unbolt that, there's a warning label right here. Warning, high voltage. You will be killed or hurt. Do not remove this cover. No customer service parts inside. And then it has battery disposal information. This 158 volt nickel metal hydride battery requires special handling and disposal process, and it gives you a phone number to call here in the United States. So the proper procedure for opening this rear cover, if you needed to change the battery, which is over here, or any of the inverter, converter, air conditioning driver, the fan, or anything else, is there's a cover right here that you take off, and then there's a switch. And you'll notice there's a on and an off right there. There is a safety button right there that you have to push to turn it back on. But there's a switch, and we've accidentally broken the switch off, but let me flip it forward. There's a little remnant of the switch right there. But to shut it off, we just slide it down. And to turn it back on, we have to push down on the red plunger and then slide it forward. So what this does when we shut off that switch is it disconnects the high voltage battery that is, all the battery modules are in series with each other. It disconnects that series circuit inside the battery and makes it to where there's no high voltage when we take off this cover, and we should be safe. But just in case, we will use our personal protective equipment, our gloves, safety glasses, and so on, to prevent damage to ourselves and any other electrical components. Okay, personal protective equipment. We are going to put on our high voltage gloves with the cotton liners on the inside and the leather outer gloves to protect the $65 a pair high voltage gloves from getting cut. This sheet metal here has lots of razor sharp edges, and you got to be real careful that you don't cut your skin, let alone the gloves that you're going to wear. I have already tested these gloves for leaks, so I'm going to skip that part of the testing procedure. I have a separate video on personal protective equipment, and you can watch that by clicking on a separate link to learn how to test these gloves to make sure they're safe to use. So I've got the outer leather gloves on to protect the inner high voltage gloves from getting cut. Okay, as I've done in previous videos, I am not opposed to using an electric impact gun or electric ratchet to remove things, or even an air-powered one, as long as you realize there's a position between off and full throttle. You can back these out slowly and make sure that you're not bringing any threads with it. Also, I never use this if the bolt that it's screwing, if the bolt screws into something plastic, because that plastic piece can get broken quite easily. So let's remove the bolts that hold this cover down. Okay, our power switch is off. I've got my personal protective high voltage gloves on. We can now lift off the cover and set it off to the side. Okay, with the cover removed, we can see some of the individual components. This whole assembly right here, from here over to here, is the 158.4 volt nickel metal hydride battery. Now this is out of a second generation Honda Civic hybrid. The first generation and the third generation batteries were 144 volt. However, the first and second generation batteries are nickel metal hydride. The third generation battery is a lithium ion battery. Now these batteries on the first and second generation had a lot of problems with longevity, durability, self-discharge. Hybrid cars on the vehicle lot with a nickel metal hydride battery needed to have the high voltage battery recharged every 90 days. There's a service bulletin for that, for sitting because of self-discharge. And the recharge procedure was you would start the engine, warm it up, and then bring the engine RPM up to whatever RPM it specifies for that vehicle. It was somewhere around 3,000 RPM or so on the one I read for this one. And then you hold that for so many minutes while the rotor assembly and the IMA motor stator assembly through electromagnetic induction would recharge this battery here. So there are service bulletins for battery warranty extensions because the batteries weren't lasting as long as they should have. If you have a Honda hybrid vehicle, specifically the Civic hybrid in the first or second generation, and that battery needs to be replaced, Honda has extended the warranty for some of those vehicles for a much higher mileage and number of years beyond the original warranty. So be aware, I mean, they're not going to cover it for life. These batteries do need to be replaced now and again, but it has a longer warranty period than it originally came with. All right, now, as you can see right here, we have a short orange wire with a negative symbol on it and a short orange wire for the positive symbol. Those two wires are the DC wires that go from the high voltage battery here to the inverter assembly, which is down underneath this. So that 16-foot long 2-wire DC cable, high voltage DC cable, that I showed you was in the 2010 Toyota Prius. On the Honda Civic, it's just this little short thing here. This less than a foot long. On the Toyotas, the 3-phase cables that went from the inverter converter down to the transmission, transaxle, were fairly short. But now, the 3-phase cable that goes from the inverter assembly clear up front to the electric motor that helps the engine's crankshaft rotate is the really long one. So Honda, basically on their IMA system, has swapped the cables, basically. You've got the short DC cables instead of the long ones. You've got the long 3-phase cables instead of the short ones. And that's just simply because all of this stuff, the inverter, converter, air conditioning driver on the Toyotas is up underneath the hood, where on the Hondas it's back behind the back seat. So it makes sense that that's what they've done. All right. Now, the battery has some lift out handles right here, but we can't lift it out without disconnecting it first. And to disconnect that, even though the power switch is off, we always want to check to see if we have a voltage on those cables before we put a wrench on there. So I'm going to turn our multimeter to DC volts. I had a viewer here on YouTube comment that in my previous video I did not test the meter and the meter leads to see if it even worked before I did some measurements on high voltage systems, and he's absolutely right. We could have a broken meter lead internally, which we've had those over the years. I told you these fluke meters are great meters, but the meter leads with continuous use can sometimes go open. So I've got a little 9-volt battery right here. I am just going to put the meter leads across that and see if we read battery voltage. And I've got 9.8 volts right there, which tells me the meter leads are not open. They're working properly, and that the meter is capable of reading a voltage. So now if I go between the positive and negative terminals here on the high voltage battery with the switch off, we should have 0, and we do. We have 0 volts. Okay, that means it's safe to unbolt those wires. That also means that it's safe to take off these high voltage gloves and use my bare skin right against either insulated tools or uninsulated tools. If you've got the insulated ones, you might as well use them. If you don't, then it's safe at this point with no voltage to take those off anyway. But to remove the battery, we have to take those 2 bolts out. I have some insulated, coated nut drivers here. This one's a 10 millimeter. So there's 1 bolt. 2. So these 2 wires here from the battery to the inverter are now disconnected. And I can just lay those off to the side. Now also right down here there is our orange cable for our voltage sense, just like we had in the episode on high voltage batteries. This orange connector here with all these little tiny wires, those little tiny wires go in and connect to each battery module inside the battery itself, and it'll tell you the voltage on each module, and you can read that on the scan tool. There's one more electrical connection right here, and that is a connection between the battery condition monitor module, the BCM, not to be confused with a body control module. This is a battery condition monitor module, but they use BCM for short. And the contactors that are, and the temperature sensors that are here on the side of the battery. So now, to get this battery out, we just need somebody capable of lifting out this, I estimate, 80-pound battery.
Hold my breath and I can do it.
Awesome. Thank you.
You're welcome.
It's perfect. Okay, as you can see, that battery module pulls out. And of course, this would be facing the front of the vehicle rather than facing up, as I have it here in the classroom. Now, there's one more module over here that contains all of the computers and the electric AC compressor driver, the DC to DC converter, the battery condition monitor module, and the inverter. All of this lifts out also if we disconnect one more electrical connector for the fan that is bolted into the bottom of the case. So now this entire assembly here get the external wire harness out of the way. That entire assembly lifts out, and now we have an empty case with the exception of the intelligent power unit fan. As I mentioned before, this fan is a brushless DC motor driven fan. Okay, I'm going to remove the fan. It just has a little wire harness clip and a couple of 10mm head bolts that hold it in place. This is a serviceable fan. There's a service bulletin for this fan, or for the fan blades getting plugged up with lint, pet hair, dirt, whatever it may be, depending on how dirty your interior may be, or maybe right at that air intake at the top of the rear speaker shelf is where a little dog likes to rest or something, and all the pet hair gets down in there. So here is our brushless DC fan motor assembly. So now we've just got this big empty intelligent power unit housing. I'm just going to set it off to the side here for a moment. Now let's take a look at this fan unit. The fan blades on this unit were very dirty, and I've cleaned them really well. There's a little clip that holds the fan blade onto the armature shaft, but it did not want to come out very easily at all. So if you need to clean one of these, I would recommend leaving it on the armature shaft and using something like a cotton swab or a little piece of a shop towel or something to clean each blade. So the fan would fit on here like this. But I took this apart because we are going to talk about 4 different types of electric motors in this series on hybrid vehicles. And this is a brushless DC motor. Notice we've got field coils in the middle and then permanent magnets on the inside of this piece that hooks onto the armature shaft. And now that is just backwards of the electric motor that's used here on the Honda hybrid IMA system, the integrated motor assist system. It has all the permanent magnets on the rotor in the middle facing outward, and then it is surrounded on the outside by the coils of wire, the field coils. So this is a brushless DC motor. This requires a specialized controller. you can see to control which field coil to pulse on and off to cause the fan blades to spin around with these permanent magnets. So that is a brushless DC motor. All right, let's look at the components that we just lifted out, all the electronic components, not counting the battery here. So on the front here, we've got a wire harness, and this harness connects to a couple of relays. It connects to the air conditioning compressor. It's the computer interface for that. It connects to the DC to DC converter right here. It connects down over here to the battery condition monitor module. And down underneath, it connects to the inverter assembly. So now that we've got those unplugged, there are two other electrical connections that we have here. This orange connector right there is for the three-phase wiring that goes up to the electric air conditioning compressor. And so we can unbolt this air conditioning compressor driver module. To do that, we need to disconnect the DC connection from the high voltage battery to both the DC to DC converter and the compressor driver. So we'll just loosen those up. And then they have mounting bolts that hold these down. So now we'll take off our positive DC cable. Just a short little cable. Keep the bolt with it. Our negative cable just a little bit longer. And its bolt. And then the two DC cables through a bus bar to the electric air conditioning compressor driver. The negative, the positive terminals, the negative and the positive terminals. Then we've got the four mounting bolts that hold this down. Looks like my coated tool is too thick. We'll have to use the uncoated standard tools here. There's a little bracket that comes off. Another mounting bolt. All right, so now this air conditioning compressor driver, we got all the bolts out. Oh, it's actually wedged underneath the DC to DC converter with a little ledge, little lip. So we'll take off the DC to DC converter. Here we go. So here comes the DC to DC converter. I can get the bolts out of it. Right there. Here we go. Now on this DC to DC converter, we've got the negative and positive terminals from the high voltage battery that connect right here. And that's the 158.4 volts. Down here, this bolt is the 14.5 volt output to the auxiliary battery. And then the bolt that holds down the housing itself is the battery negative for the 12 volt system. I want you to notice this has cooling fins on the back of it because this is an air cooled. We just looked at the fan. This is an air-cooled system. So unlike the Toyotas and a lot of other hybrids that are out there that have liquid-cooled components, these are not liquid-cooled. These are air-cooled. So we've got to be careful not to damage these fins. We want to make sure that everything is good and clean in there, not full of lint or dirt or whatever. And so we can service this entire DC to DC converter as one part. And you would probably do that if your 12-volt battery kept going dead and you didn't have any trouble codes. The system check for the 12-volt battery is to turn the vehicle on, put a voltmeter on your 12-volt battery, and if it doesn't read around 14 to 15 volts, then your DC to DC converter is probably not working correctly. But remember, it can't work correctly unless its power feed from the high voltage battery is good. Now, this is a huge problem on Hondas. There's even a technical service bulletin, maybe it's even a recall for the battery, the high voltage battery going dead, that stops the DC to DC converter from working properly, that then doesn't charge the 12-volt battery, and the car could stall or die as you are driving around. And so that's no good. So if that's happening on your car, check for service bulletins and see if the bulletin or recalls out there apply to you. Now, with that DC to DC converter removed, we can remove the air conditioning compressor driver assembly here. Oh, I've just got one bolt that's stuck. There we go. Okay. So our power and ground coming in from the high voltage battery, and then a 3-phase cable output. Notice it's orange. This is high voltage, the 158 or so volts, to drive the electric air conditioning compressor. Air cooled also with the little cooling fins. So that's our air conditioning compressor driver. We can remove the battery condition monitor module now. It's just got a couple of nuts that hold it in place. Once again, a serviceable unit. By the way, there's been several software updates for these modules, firmware updates. The battery controller update also. Whenever you put in a new battery, you should always make sure you've got the latest software update in it, the battery condition monitor module, and any other programmable components. So there's our battery condition monitor module right there that monitors the voltages and the temperatures of the high voltage battery. Okay. Now, if we flip this over right here, on the back here we have a shield that covers the inverter assembly. There's also the capacitor module back here. Okay, to remove the inverter and capacitor module assembly, we've got to take off this plastic cover in the front that that covers the DC bus bar. So it's got some plastic little clips with a Phillips head screw on them. I'm just going to take those out real quick. We're just going to unscrew those just like a screw, any other screw, and take them out. If they fight you coming out, if they just turn and don't want to come out, then put a little tension on the back of the housing that you're taking it out of, and it'll help it to unscrew. And then one more. Okay. All right, so now this cover can just lift up. Keep track of those little clips because they want to go flying all over the place. But here's the cover. Here's the DC bus bar. The same two orange wires that connect to the high voltage battery that also connect to the DC to DC converter and the air conditioning compressor driver also connect to the inverter assembly here. So now we will take off those two bolts. So here's our DC bus bar. Just has 6 connections, 3 positive, 3 negative, that connect to the high voltage battery. And the purpose there is to take current from the battery for the DC to DC converter and the air conditioning compressor driver, and to take current from and put it back in the battery from the inverter assembly here. All right, now we got to take this shield off and the rest of the harness. So there's just some little plastic clips that hold the harness in place. And then there's a ground wire on the harness on one of the bolts that holds down this cover. We can't quite lift the cover off. There's 2 more bolts and a shield on the other side. I was hoping we could, but it won't let us. So if we turn this back over, lift off the wire harness, release the little clips that hold it in place. Now we can set that off to the side. Let me get those relays off of there. There we go. Okay, so here's our wire harness. We'll just set that off to the side. And then we've got 2 bolts right here that hold a shield in place that covers up the connection where those 3 wires, the big heavy orange wires from the inverter all the way up to the integrated motor assist stator assembly, where they connect. All right. So if we look closely here, we have 1, 2, 3 electrical connections. This is the W phase, the V phase, and the U phase right there. That's where our 3 big heavy orange cables come in and connect. So now we can lift this up. The cover for the inverter comes off. So now we have a capacitor module on the top here that's held down with 4 bolts. And then we have 4 bolts that hold the inverter converter assembly down. That's all one piece from Honda. So if we just take out the 4 outside bolts, and they're a little longer than the short bolts that we've been taking out up to this point. Now the inverter assembly can lift out. And of course, notice it's air cooled also. We've got our positive and negative posts from the high voltage battery right here, from and to the high voltage battery. And then our 3-phase cable outlet wires, outlet and inlet. So outlet as we're accelerating and driving the crankshaft of the engine, inlet as we're slowing down and receiving power from the integrated motor assist motor assembly there in the form of regenerative braking. So we can set that off to the side. Right here on the top, or on the DC input side of the inverter converter assembly, are 2 more little plastic clips. Once again, this entire assembly has to be replaced as one assembly from Honda, but I like to take things apart as far as I can get them without destroying anything. And this does come apart one more level. There's a little plastic shield here on the front that comes off. And now we can see 6 bolts in there that connect 3 capacitors just like we saw in the inverter or the series video on inverters and converters a couple of weeks ago. There were 3 great big capacitors in the first generation Toyota Prius, and they had 6 electrical connections to them. Well, this is the same 6 electrical connections. So let me get those 6 bolts out of there. And these 6 connect to the exact same positive and negative DC terminals here. And the purpose of those capacitors is to smooth out, they're actually called smoothing capacitors, smooth out the rippling voltage from the stator as we are decelerating and taking advantage of regenerative braking. We take a AC sine wave, 3 of them, 120 degrees apart, and invert the negative portion of that, flip it over and make it positive. That way it's all DC. Now we've got 4 bolts that hold the capacitor module to the inverter. So the capacitors smooth out the full wave rectified AC voltage during deceleration. So here comes the capacitor module right here. It says right on the top of it the size of the capacitors. They are 600 volt, 458 microfarads, and there's 3 of those. And then there's a 33 microfarad and another 33 microfarad that are off to the side here and with these little tiny wires. But these 3 big ones here are approximately 458 microfarads a piece. So now we can see the actual inverter assembly here. If we peek down the sides here, you can see there are 3 distinct modules in there, one for each phase of the AC voltage that is used to drive and is used for rectification in charging the battery when you decelerate. So just a quick review of what an inverter assembly does. We have the DC voltage from the high voltage battery. DC, 158.4 volts. Then the inverter assembly uses insulated gate bipolar transistors, IGBTs, to toggle that DC and run it through the 3-phase coils of the IMA motor assembly over there, and it creates a simulated sine wave, 3 of them, one for each of these modules here, 120 degrees apart out of a 360 degree rotation that pulls the permanent magnet rotor assembly around and helps the crankshaft rotate. So we take DC in, we create AC voltage going out, 3 different phases of AC, 3 identical phases, but they're just shifted in time, 120 degrees. And then when you decelerate, we don't use the IGBT transistors during deceleration. We use the rectifier bridge. There's 6 great big diodes in here that when you decelerate, just like an alternator on a car that has a rectifier bridge, those 3-phase AC voltages created by the IMA stator assembly over there through electromagnetic induction are sent over here and run through this rectifier bridge that flips everything back over to DC, and then except it's a bumpy DC, and then the smoothing capacitors smooth it out into a nice smooth DC that's then fed back to the high voltage battery. Okay, so on the passenger side of that great big intelligent power unit box that we had here. One more time, we've got the DC to DC converter, we've got the air conditioning system driver, we've got the capacitor module, we've got the inverter assembly, and we have the battery condition monitor module. All 1, 2, 3, 4, 5 pieces, plus the electric fan. It's a variable speed DC brushless fan over there. And we've got the DC bus bars that are the equivalent of just having more positive and negative DC cables run to each of these components, but they just do it with a heavy bus bar instead of additional wires. Okay, so that is the passenger side of the intelligent power unit assembly. Now let's look at the battery side, the driver's side, and what is here and what is serviceable and what we can see in the battery.